to video 2 of section 3 of our Solutions 1 unit. You should take out your titration diagram that is in your folder, and we're going to go over the steps of a titration using a diagram. So, I apologize for the crudely drawn diagram, but it's the best of my artistic ability. So, this would be a representation of a burette. It's a large tube. Our burettes in class hold or graduated to 50 milliliters, and it's a reverse scale. So it starts with 0 milliliters on the top and 50 milliliters are on the bottom. So when we fill this up, we want the meniscus to be at 0, because just like with a graduated cylinder, we always read our volume at the bottom of the meniscus. So if we look at this, down here towards the bottom is going to be our valve that is called the stopcock. That controls the amount of fluid that releases into, in this case, an Erlenmeyer flask, and then we can know how much of this is going to be used. We always want to read this to 2 decimal places. So this is highly graduated, and these are very expensive equipment. The more marks between the milliliters, the more expensive things usually are. So we're always going to record volume to the hundredths place. So 2 decimal place values. The last one is estimated. So try not to use 0 and 5 as your last estimations. So inside of this burette is going to be a standardized solution. In our previous video, we talked about what a standard solution was. So this one we are going to have a known concentration, and the volume used will be recorded. And we're going to prepare this solution using a primary standard. And we'll go over what primary standard that we typically use in our next video. So down here at the bottom in the Erlenmeyer flask, we're also going to have a substance. This is going to be unknown concentration. That's usually one of the goals of titration, is to determine the concentration of one of the reactants. So in a burette we have a known concentration, and we're going to have a volume once we know how much reacts with the solution in the unknown. We also have our indicator. So as we add this standardized solution into here, it's going to react with this solution until all of this is used up. And it's usually a known amount. So we're going to know the volume, or we're going to know how many grams was dissolved in here. So if we know the volume and the concentration up here, and we know the amount down here, we can figure out its concentration. Typically we use either grams or milliliters. So we have to carefully measure things with the titration. So now what we know is in everything, now we have 3 main steps that we use for titrations. And I'm just going to write those up here alongside. So our first step is we have to determine the concentration of the standard solution. Using a primary standard and titration. So what we're going to do is we're going to put our primary standard, a known number of grams, into the flask down here at the bottom. We're going to add water in order to dissolve it, and we're going to put an indicator. The solution that we're trying to standardize, we're going to put in here. We kind of switch things around a little bit with this titration because we're trying to figure out what concentration is in here. So when we add this substance into our flask, it's going to react with our primary standard, and once all the primary standard is used up, it's going to turn a specific color. And the demonstration by the learning facilitator will demonstrate what this looks like. So once we do that and we figure out through stoichiometry what is the concentration of the solution in this burette, we can add the standard solution to an unknown solution in the flask until the endpoint is reached. And once we know that endpoint, we can use stoichiometry to calculate the unknown substance and its concentration. So that's our last step. And our ultimate goal is to find out what is a concentration of the substance in the flask. And we have to go through several steps in order to do that. Our next video is going to go through an actual problem so you can see how this works with the math.